Hi everybody, what we're going to do in this video is I want to show you how to do a chi-square for independence. And basically all it is you're measuring to see if the two variables, in this case gender versus color preference, is independent. In other words, there is no relationship between the genders and paints that to influence, or if there is a relationship. In other words, the two variables do depend on each other for their paint preference. Now, because of time that I have to do this video, I've already set up all of your tables for you and the sheet that suggestion table that I suggest that you work on. All right, first again is establish your hypothesis, which I already showed you. No hypothesis is always going to be no relationship, and I already had summary data from the source where I got the data from. So I already set up the 2x2 contingency table, and what I had to do then afterwards is copy and paste this table to another cell, and instead of being observed cells, they're going to be the expected cells. So basically what I had to do was clear the interior cells of these numbers so I can get the expected. I'll show you how to do that in a moment. Now, you should already establish your alpha level or probability. In this case, it's going to be 0.05. And your degree of freedom is 1 because you got 2 minus 1 for your gender, and you got your 2 minus 1 for your paint, and times that together, and you got 1. And you can see the formula that I got it up there. Remember, degrees of freedom is n minus 1. And I set up another table where it reflects the actual formula, which is observed minus expected, and you have to square that and divide it by the expected. So in one column is the observed minus the expected, and another column is you square the observed, and another column, here's your final column, is your is divide the square root by the expected number. Alright, again, to get the expected numbers, all you're doing is you're taking your marginal totals, and in the observed category, so this one is D5 times B7. So you're doing your two marginal totals, and you're going to divide it by the overall totals. And so I did that for each one. Click into the cells so you can see the actual formula that I did, and it should add up to the same totals as that I have up here. Observed is what you have collected. Expected is what you think the totals in each cell will be. Remember, this is all frequency count. Now, after you do that, then you can come over here to this table, and what you want to do is you take your observed number, in this case, men and white paint, and the observed is 180, so that's B5 minus B12, the expected, and you come up with that number. So do it for each one, and again, if you click into the cells, you can see the actual cells that I use for the subtraction. Then once you get the number here for this column, now you want to square it. And again, square is just a number times the number, or you could actually do the power command, which just asks you for the number and what your power is going to be. And you can also find that, by the way, under the math and trig, and it's right there. All right, once you have all that, then you can now do the final column, because you're going to have to, your main goal is to get the chi-square test statistic. And here, all it is taking your square that you've already done and divide it by, in this case, B12. Find B12, and there it is right there, the expected. So if you do it for each one, you can then, again, click into the cell. You can see the actual formula that I used. And then once you finish doing that, then all you need to do is just total up the column here. This is for the total chi-square, and you come up with your chi-square test statistics. Because what you're going to do is you're going to see if you're going to compare your chi-square test statistic to your critical value. That is the on the normal curve is your boundary. And the way I got this is I used the CHIINV command. So if I type in equation CHIINV, there it is. And basically what it's doing is asking for your probability. That's why I say always have it established. And your degree of freedom. Close it. And I come up with the same number. And you want to come up with a p-value also. And a p-value, use the chi-square test. So if I type in chi-square test, there it is there. And now it's asking for the actual observed range right there. Don't include any labels or the totals. And comma, now it's asking for expected range. There it is. And there, I came up with the same p-square. So, since the calculated p-value of 0.00 is less than the alpha level of 0.05 and the calculated chi-square of 14.27 is greater than the critical value of 3.841, you know to reject the null hypothesis. And also, just to let you know, your degree of freedom is 5 and your alpha level is 0.05. So if you go to a chi-square table, go to degree of freedom, scroll over to 0.005, and there's the same number, 3.841. And therefore, we are going to reject the null hypothesis. Gender and paints are related to each other, and gender possibly does influence your paint preference. Remember, this is only measuring the relationship. It's not measuring why there is a dependency upon gender in paint. That you would have to do another study where you can ask people why. Now, in the Excel practice sheet I gave you, there's 2 more to go. I gave you the actual answer. See if you can replicate exactly what I have done. All right, that's about it. If you have questions, remember to always ask questions. This is Doc Chasen, signing off.